Let f be a function from a set x to a set y. Consider the following statements. So the statements are called P, Q, and R. Statement P says for each x in x, there exists a y in y such that f of x is equal to y. Okay. Option Q, for each y in y, there exists x in x such that f of x is equal to y. And statement R, there exists x1, x2 in x such that x1 is not equal to x2, and f of x1 is equal to f of x1 is equal to f of x2. The negation of the statement f is 1 to 1 and on to y is one of these options. Oh my goodness. Okay. So what's a little bit interesting is that option P doesn't really say anything. Option P is simply saying that f is a function from x to y. So, right, if I write down option P, says that for all x in the set x, there exists y in the set y such that f of x is equal to y. This is just saying that, you know, but we have given as a statement before this that f is a function from x to y. And what does it mean for f to be a function from x to y? It means that for all x, there exists a y. Or for all x in x, there exists a y in y such that f of x is equal to y. I mean, there's a little bit more to it than a function, but that's pretty much it. Okay. Now, the statement Q, I noticed as I was reading this, so this says that for all y in the set y, there exists x in the set x such that f of x is equal to y. So this is equivalent to, this says that the function f is surjective, right? It's saying that for any value of y, I can find an x that works here. So this is onto. That's the definition of being onto. And statement R has something to do with being injective, or 1 to 1. It says that there exists x1 and x2 in x with x1 not equal to x2 and f of x1 is equal to f of x2. So this is the definition of not injective. If I have different x1 and x2, but the function is equal to these 2 points, this says not injective. So, not injectives, so not 1 to 1. I don't like when the phrases 1 to 1 and onto are used in a setting like this. Most people who are writing a test should be at a level where they're calling things either injective or surjective. Okay, so f is 1 to 1 and onto. That statement is the same as Q and not R, right? So it's onto and not 1 to 1. So that is equivalent to the thing in quotes. But we want the negation of this. So the negation of this is either not Q or R. And let's see if that is one of the options given in the multiple choice selections. It is. I think that's option C. Option C says R or not Q. R or not Q. So that'll be my answer, option C. Yeah, it doesn't surprise me that statement P doesn't make an appearance in the actual correct answer. Obviously, the fact that P exists in some of the other multiple choice selections, fine, but those are not the correct answer. Because if you read what statement P says, it simply says that f is a function. Fine. We already know f is a function. Yeah, so this question, it tests a couple of things. It tests whether you can make a precise statement, let's call it a set theoretic statement, which are equivalent to a function being injective and surjective. And then it also tests whether you can work out the logic of how to take a logical negation of a logical statement like this. So, I mean, if you have two statements, A and B, the negation of that is not A or not B. So the and flips to an or, and the two statements flip to their negation. So that's essentially all I've done here. I've sort of distributed the negation through and flipped the and to an or. If I have a mistake somewhere, I'll let you know. Thanks for watching.